Conceived in the free-spending Cold War era to be unassailable in air combat, the Lockheed Martin F22 Raptor was born into a less certain world in which the nature of air combat has changed and where funding is far from assured. Belatedly adding an air-to-ground capability to its repertoire greatly aided the Raptor in its budgetary fight on Capitol Hill, and the aircraft is now in full production after a lengthy development program, albeit with significantly fewer numbers than was once envisaged. Nevertheless, the combination of stealth, high-speed supercruise, thrust-vectoring engines, data link and state-of-the-art integrated sensor-fused avionics place the F-22 in a class of its own, and it will spearhead the US Air Forces for decades to come. Like the F-15 Eagle it's replacing, Lockheed Martin's F-22 design is a large aircraft, enabling it to carry a significant fuel fraction within its frame to give it a healthy range. In terms of performance and maneuverability, the F-22 has no equal in the fighter world. Crucial to its superiority is its supercruise ability. While several aircraft, such as the Eurofighter Typhoon, have this ability, none can match the Mach 1.82 figure quoted for the F-22. Supercruise allows the F-22 to fly at high Mach numbers for extended periods. For other aircraft, the use of afterburner to achieve such speeds greatly increases fuel flow and reduces the time at which these speeds can be sustained to a short duration dash. Quite apart from its low observability, the F-22's ability to fight at continuous high speeds makes it very difficult to shoot down, as it presents missiles with almost insoluble geometry and energy demands. Using afterburner in short bursts, the F-22 can get to Mach 2.25, while at low level it can reach Mach 1.4. F-22s can also quite happily fight at 60 to 65,000 feet altitude, way above the upper levels achieved by other fighters. This translates into longer weapons range. The powerful engines allow the F-22 to reach such altitudes very quickly, suiting it for the interception role. Although intended to be all-conquering in long-range engagements, the F-22 also has a requirement to be highly maneuverable. Rules of engagement sometimes preclude beyond visual range engagements, so the F-22 has to be able to mix it with fighters at short range and win. At the heart of the aircraft's low-speed super maneuverability is a thrust-to-weight ratio of about 1.4 to 1, a typical combat weight, a figure unmatched by any other fighter. An advanced flight control system, thrust vectoring, and powerful control surfaces provide controllability throughout the aircraft's considerable envelope, while the powerful engines and clean aerodynamics maintain high energy levels even during violent maneuvers and at massive angles of attack. F-22 pilots have demonstrated stable, controllable flight at alpha figures of 60 degrees positive and 40 degrees negative. The F-22 has G limits of +9 and -3. It can also sustain 6G at Mach 1.8, giving it the kind of extraordinary high-speed maneuverability that makes it unbeatable in long-range high-speed fights. Even without its stealthiness, the F-22 would be an unstoppable opponent in air combat. The requirement for stealth for first-day missions imposes some restrictions on the range of weapons that the F-22 can carry. To meet its low observable requirements, it must accommodate its weapons internally, in bays covered by flush-fitting doors with sawtooth edges that trap radar energy. Perhaps surprisingly for an aircraft with the capabilities of the F-22, a gun is installed. The weapon is the M61A2, a lightweight version of the trusty Vulcan 20mm rotary cannon, fitted to most US warplanes. The gun is mounted above the starboard intake, its muzzle being covered by a rotating, flush-fitting door when not in use, to maintain stealthiness and preserve what is known as the low observables bubble. The gun uses linkless ammunition held in a closed-loop conveyor belt assembly. On either side of the engine intake trunks are bays sized to carry a single AIM-9 Sidewinder each. The bays are big enough to carry the older AIM-9M, which was fired in early trials. The principal short-range weapon, however, is the Raytheon AIM-9X, an advanced version with an imaging infrared seeker and thrust-vectoring tail control. Sidewinders are carried on LAU-141 launches in the side bays. When the bay doors open, the LAU-141 extends out into the airstream, with the Sidewinder angled out so that it clears the aircraft's nose when it's fired. The Sidewinder launches straight from the rail. As soon as it's fired, the launcher retracts and the bay doors are rapidly closed. When the doors are open, the aircraft's radar cross-section increases, breaking the LO bubble, and the time that they are open is therefore kept to a minimum. The primary weapons are carried in two large side-by-side bays underneath the fuselage. Again, they're covered by rapid-action doors. The relatively cramped dimensions of the bays dictate what weapons can be carried within. The F-22 was designed as a dedicated air-to-air fighter, so the bays were sized to accommodate the AIM-120 AMRAAM missile. The initial AIM-120AB versions have large fins, and only two could be carried in each bay. A new version known as the AIM-120C compressed carriage AMRAAM was produced for the F-22 and other stealth aircraft that needed to accommodate weapons internally. This has cropped fins so that three can be accommodated in each bay, slightly staggered so that the fins overlap. They are carried on EDO LAU-142 AMRAAM vertical ejector launchers, or AVELs. Each AVEL consists of a pneumatically actuated trapeze that throws the AMRAAM vertically downwards into the airstream before the missile's motor ignites. The AVEL has a 9-inch stroke and ejects the missile at more than 25 feet per second. Long before a production F-22 took to the air, the world changed dramatically with the end of the Soviet Union. In the post-Cold War climate, it became increasingly difficult to justify a very expensive single-role air dominance fighter. In 1994, the United States Air Force decided to add a secondary ground attack capability, and this facet has steadily grown in importance. For a while between September 2002 and late 2005, the Raptor was officially known as the FA-22 to emphasize its dual-role capabilities to a potentially hostile Senate. Constrained by weapon bay dimensions, the initial air-to-ground load was limited to just one 1,000-pound GBU-32 Joint Direct Attack Munition or JDAM in each of the under-fuselage bays. Carrying 2 JDAMs displaces 4 AIM-120Cs, but a single example of the missile can be squeezed in alongside the bomb in each bay. In-flight drops of JDAMs got underway on the 23rd of April, 2004. For the time being, the GBU-32 is the F-22's only cleared air-to-ground weapon. While this may seem an insignificant load, it should be remembered that the GPS accuracy of the weapon allows it to be delivered to within a few feet, and that from the F-22's operating altitude of well over 40,000 feet, it has a range of around 15 miles. The JDAM was released by gravity from the bay, its smooth separation from the aircraft being facilitated by a small deflector plate that deploys into the airstream from just forward of the bay. More important in the immediate future is the 250-pound GBU-39 small diameter bomb, a GPS-guided weapon that has pop-out wings that could give it a range of up to 46 miles when released from altitude. SDBs can be carried 4 at a time on a smart rack in each bay for a maximum of 8. The F-22 can still carry an AIM-120C in each bay as well. For missions where stealth is not a requirement, the F-22 has the ability to mount 2 or 4 underwing pylons, each rated for up to 5,000 pounds. They can be used for fuel tanks or for the carriage of additional weapons, including bombs and missiles on twin racks. An interesting feature of the wing pylons is the ability to provide self-deployment carriage for missiles on long-range ferry flights. Each wing pylon can carry a fuel tank below and the bodies of AMRAAM missiles on shoulder positions. The missile fins are removed for carriage in the side bays. In this way, the F-22 can self-deploy with its normal armament of 2 AIM-9s and 6 AIM-120s, but can also carry a further 8 missiles to its deployment destination. The F-22's weapon system represents the state-of-the-art in terms of integrated sensor fusion. Spearheading the system is the Northrop Grumman APG-77 radar, a highly advanced unit with an active electronically steered antenna array consisting of perhaps as many as 1,500 individual transmit-receive modules that can work in many different modes. The array is fixed and angled slightly upwards for low observability. Despite being restricted to a sweep of 60 degrees either side of the center line, the ASA array gives the APG-77 very high resolution for long-range target identification and the ability to form very fine beams to reduce the probability of the radar being intercepted. It also uses adaptive power so that its signal is reduced to the minimum necessary to accomplish the task, further reducing its vulnerability to detection. In the near future, upgraded F-22 radars will offer increased ground mapping capabilities to expand the aircraft's air-to-ground prowess. A capability that has been hinted at is the ability to focus high-power beams on cruise missiles, the radar's power being able to knock out the missile's electronic circuits. The APG-77 is just one element of an integrated system. Antennas for a comprehensive communication, navigation, and identification friend or foe system are buried conformally in parts of the wing and fin edges. The combined CNI system manages transmissions across a wide frequency spectrum, and its antennas are also used to feed radar warning and other passive information into the aircraft's 2 central integrated processors. Here, information is analyzed and fused to present a combined display to the pilot. An important communications asset is the Intra-Flight Data Link, or IFDL, which allows the F-22 to send and receive information with other F-22s in its formation, and with other air and ground assets. Data received via the IFDL is added to that from the aircraft's own sensors and fused by the CIPs into single target tracks. Raptor 06 tested much of the avionics suite. The F-22 is well defended with a comprehensive warning and countermeasures suite. The BAE Systems ALR-94 is a passive receiving system that's accurate enough to identify and track hostile radar emissions, to the point that it can cue the APG-77 radar. The F-22 is fitted with a range of jamming options, including the ability of the APG-77 to be used in jamming mode, and it has mechanical dispensers for chaff and flares. Sitting underneath the one-piece low observable canopy, the Raptor pilot is at the controls of the most advanced fighter in the world. Not surprisingly, the F-22's cockpit is also among the most advanced flying in a service fighter, although it lacks the direct voice input of the Typhoon and Rafale. This was deemed unnecessary by Lockheed's cockpit designers. The instrument panel is topped by a 30-degree head-up display, although in the future this may be removed if a helmet-mounted display is fitted. At present, the helmet sight is of low priority for the F-22. Below the HUD is the main data entry panel, called the Integrated Control Panel. Either side of the ICP are two small upfront displays, the left-hand screen being used to present data from the communications, navigation and IFF system, and the Integrated Caution Advisory Warning System. The right-hand UFD displays the Standby Flight Group, comprising basic aircraft information such as an artificial horizon. It is connected to the last resort power source on the aircraft and should provide sufficient information for the pilot to continue flying if all else fails. In the center of the panel is the primary multifunction display, an 8-inch by 8-inch screen usually used to present the overall situation display. Surrounding the primary MFD are three secondary 6-inch by 6-inch displays for a variety of information. Typically, the left-hand display will be used for threat and defense information, the lower MFD for stores management, and the right-hand screen for detailed attack data. All MFDs are full-color active matrix liquid crystal displays that can remain clear even in the brightest sunlight. Control of the system in combat is effected by switches on the throttles and the side-mounted control stick. The pilot sits on an improved version of the proven ACES 2 ejection seat. At the rear of the left-hand side console is a box that contains an integral boarding ladder. Key to the F-22's amazing performance is its F119 engine, rated at around 23,500 pounds thrust without afterburner and 35,000 pounds width. Pratt & Whitney began development of a joint advanced fighter engine in 1983 under the company designation PW5000. The engine was later designated F119 by the US Air Force. The F119 uses counter-rotating spools and advanced metallurgical processes to produce a very light but enormously powerful engine, controlled by a full-authority digital system that optimizes engine performance. The intakes are fixed, a requisite of the F-22's stealth design, but are optimized for operation at high supercruise speeds. Their position and shape allows for maximum airflow at unusual aircraft attitudes. They stand proud of the forward fuselage to avoid ingesting the sluggish boundary layer of air. The intake ducts snake upwards and inwards into the aircraft so that the engine's compressor faces are completely hidden from radars. The engine exhausts through a two-dimensional nozzle that is built as part of the engine structure. The nozzles consist of two surfaces, which can vector the thrust up to 20 degrees up or down, and can close or open the exhaust aperture to optimize the jet thrust. As well as operating simultaneously for pitch control, the nozzles can also operate differentially to aid roll rate. Aerodynamic control surfaces comprise large ailerons mounted well back on the aircraft, giving maximum authority. Like the nozzles, they operate in parallel for pitch control or in opposition for roll control. Maximum deflection is plus 30 degrees and minus 35 degrees. The fins mount powerful rudders for yaw control, but due to being canted outwards by 28 degrees, as demanded by the stealth design, they also impart small pitch and roll moments. In standard rudder mode, the surfaces deploy plus or minus 30 degrees, but they can also be used as air brakes, both of them deploying outwards through 30 degrees to dramatically increase drag. The wings have outboard ailerons that move through plus or minus 25 degrees, and inboard flaperons that can deflect from plus 25 degrees to minus 35 degrees as ailerons, or droop to 35 degrees to act as flaps. Full span leading edge flaps with a maximum movement of plus 5 degrees to minus 37 degrees complete the movable surfaces. The complex aerodynamics are handled through a triple redundant digital fly-by-wire system that commands the various surfaces and the engine nozzles to achieve the desired control inputs, taking into account the aircraft's speed and attitude. At low speeds, the wing surfaces are usually drooped to increase lift. The first EMD F22A flew at Marietta on the 7th of September 1997 with Paul Metz at the controls. After flying in Georgia for a while, it was disassembled and flown in a Galaxy transport to the Air Force's main test center at Edwards Air Force Base in California. At Edwards, a combined task force was established to operate the 9 EMD aircraft staffed by industry and Air Force personnel. By April 2002, all 9 aircraft had flown, followed in the autumn by the first 2 of an eventual 8 production representative test aircraft. 2 of them, plus the final 2 EMD aircraft, were used in the crucial initial operational test and evaluation undertaken in 2003, which determined that the F-22 was suitable for service. Meanwhile, on the 7th of January that year, the Air Force's Air Warfare Center received its first Raptor at Nellis in Nevada, to be operated by the 422nd Test and Evaluation Squadron of the 53rd Wing. The Nellis-based 57th Wing later received Raptors for its fighter weapons school. Training of frontline F-22 pilots is assigned to the 325th Fighter Wing at Tyndall in Florida. This unit also handles F-15 training. The first F-22 squadron was stood up in October 2002 to prepare for Raptor operations. And on the 26th of September 2003, the 43rd Fighter Squadron received its first aircraft. Training operations are now in full swing at Tyndall with a full complement of 18 aircraft. Langley Air Force Base in Virginia is the home of the first frontline unit, the 1st Fighter Wing. In January 2005, the first F-22 arrived to begin replacement of the F-15 Eagle with the 27th, 71st, and 94th Fighter Squadrons. After training hard to get combat ready in their new mounts, the Langley Raptor pilots began undertaking operational commitments in support of US Homeland Defense missions in January 2006. The next base to receive the Raptor will be Elmendorf Air Force Base, home to the 3rd Wing, whose 90th and 525th Fighter Squadrons will fly the type from early 2007, backed up by a Reserve Associate Unit, the 302nd Fighter Squadron. Raptors will also be based in New Mexico with the 49th Fighter Wing at Holloman Air Force Base, and in Hawaii, where they'll be operated by the 199th Fighter Squadron of the Air National Guard, augmented by the Reserve's 531st Fighter Squadron. From the outset, the F-22 was designed to fight in the most hostile of air environments, able to operate in an area of densely packed, multi-layered integrated air defense systems, and against the best fighters that the opposition could field. Since the Raptor has gained an air-to-ground capability, its basic role is divided into 2 missions: air dominance and attacks against high-value assets. In the air dominance role, the Raptor uses all of its unbeatable air-to-air capabilities to perform a wide range of fighter duties such as sweep and the protection of high-value platforms. Air dominance implies just that. No enemy aircraft can operate in airspace covered by the F-22, allowing other friendly air assets to go about their business unhindered by hostile fighter activity. In the attack role, the F-22 is used to spearhead the US air assault, taking out key targets such as air defense nodes in the first strikes of the air campaign. Thanks to its stealthy properties and air-to-air prowess, it can perform what is called the first day mission unaided. To enable the F-22 to fly safely in hostile airspace, it must carry air-to-air missiles so that it can fight through any opposition it encounters. AIM-9Xs are loaded into the side bays, while one AMRAAM is loaded into each of the lower bays. For the attack mission, the F-22 can carry either a single GBU-32 1,000-pound JDAM in each of the lower bays, or alternatively, 4 250-pound small-diameter bombs. Most missions would involve a refueling, so that the F-22 could top off its tanks prior to entering hostile airspace. The F-22 can carry up to 4 fuel tanks externally, although they and their pilots would have to be jettisoned prior to reaching the danger area to preserve the F-22's stealthiness. As with most modern aircraft, the F-22 employs a mission planning aid that allows a pre-planned route that takes the aircraft around major threats to be loaded directly into the aircraft's navigation system. On day 1 of the war, however, it's more likely that the F-22 will be attacking those threats. Before the mission, the F-22 is prepared by ground technicians, who pay special attention to the stealthiness of the aircraft, ensuring that the airframe is clean. With all systems checked out, the F-22 launches. Surprise is the name of the game when attacking a fully integrated air defense system. The F-22's Super Cruise capability allows it to approach at a much greater speed than traditional attack aircraft, without the telltale infrared signature of using afterburner. Its stealthy properties allow it to remain completely undetected at best, or at least untrackable by ground radars. It uses an extensive array of passive sensors to build a picture of the enemy's systems without any electronic emissions, while those that emanate from the aircraft's radar are concentrated into a fine beam to give a very low probability of them being detected by the enemy's passive systems. Against enemy fighters, the F-22's attributes give what is called first look, first launch, first kill capability. Stealth greatly reduces the range at which the opponent can detect the F-22, while against a non-stealthy aircraft, the Raptor retains the full range capabilities of its own radar. This means that the F-22 can remain undetected by the other fighter until it gets very close to it. Stealthiness gives the F-22 a wide margin of superiority that can be readily exploited. The Raptor can either fire an AMRAAM at very long range in total safety, or it can approach much closer to the opponent than would otherwise be possible in a non-stealthy fighter. The closer to the target that an AMRAAM is fired, the greater the kill probability. This effect is further enhanced by the Mach 1.8 Super Cruise capability of the F-22. Launching a missile at this speed imparts more kinetic energy than is achieved when firing at lower speeds. When an AMRAAM is fired from long range, its no escape zone decreases significantly by the time it reaches its target. Firing a missile from short range means that it can maneuver harder and for longer, so that its no escape zone is huge. First look, first launch, first kill is the key to the F-22's ability to provide air dominance. Raptor pilots expect to be in the position in which the first the enemy knows about their presence is when the missile hits. The F-22's air-to-ground weapons are GPS guided, giving them accuracy that can be measured in feet, and the aircraft's high-speed, high-altitude launch allows them to be dropped at long ranges from the target. The SDB in particular has a very long range thanks to its pop-out wings. The weapons can be independently aimed against numerous targets. Once an enemy's air defense system has been degraded to a relatively benign state, F-22s can operate in less stealthy configurations using the wing pylons. While this obviously makes them more visible to radars, it does allow them to carry many more weapons into the battle zone. The origins of today's F-22 can be traced back to the mid to late 1970s, when advances in Soviet weaponry threatened to challenge the technical superiority traditionally enjoyed by the United States. New surface-to-air missiles were being developed, while the prototypes of the MiG-29 Fulcrum and Su-27 Flanker hinted at fighters that could possibly outperform the F-15 and F-16 in the future. In April 1980, the United States Air Force launched the Advanced Tactical Fighter Program. ATF demanded an aircraft that could outfight any current threat or any notional future aircraft, what came to be known as Flanker Plus. It also had to be capable of tackling airborne early warning aircraft to deny airspace control to the enemy. A request for information was issued in May 1981, followed by a final request for proposals 2 years later. The requirement for stealth technology was included in the RFP. 7 companies, Boeing, General Dynamics, Grumman, Lockheed, McDonnell Douglas, Northrop, and Rockwell, were awarded concept definition contracts in September 1983. while General Electric and Pratt & Whitney were picked to work on new engines for the ATF. By May 1986, it was clear that the ATF represented a huge technological step. The combination of high performance and stealth in a single airframe entered truly unexplored areas. In the interests of risk reduction, a flight demonstration program was deemed prudent. As the United States Air Force studied the various proposals, it also became clear that Lockheed and Northrop were some way ahead of the others, thanks in no small part to their expertise in the area of all aspects stealth. On the 31st of October 1986, both companies were awarded contracts to build two demonstration and validation, or DEM-VAL aircraft, one of each pair to be powered by General Electric's F-120 engine and the other by Pratt & Whitney's F-119. For the DEM-VAL phase, Northrop teamed with McDonnell Douglas, while Lockheed joined forces with Boeing and General Dynamics, subsequently buying out the latter. For Lockheed, the competition started badly, its initial ATF design being shown by computer predictions to be unflyable. A complete redesign was necessary, and it was not until May 1988 that the design of the YF-22 technology demonstrator was frozen. Northrop's YF-23 was first to be rolled out on the 22nd of June 1990. It first flew at Edwards Air Force Base on the 27th of August. 2 days later, Lockheed revealed its YF-22. Both aircraft exhibited all the hallmarks of stealth design, carefully blended curves mixing with sharp edges that were arranged along a limited number of alignments. Doors and panel lines had sawtooth edges. The YF-22's control surfaces had unusual notches to reduce radar returns. The Lockheed aircraft looked more conventional, and its shape alone hinted at extraordinary maneuverability, backed up by the installation of thrust vectoring. By contrast, Northrop's unofficially named Black Widow 2 looked like something from a sci-fi movie. Its shape suggested speed and stealth. The first YF-22 with General Electric YF-120 engines took to the air from Palmdale with Dave Ferguson at the controls on the 29th of September 1990. The second aircraft with YF-119 engines was flown by Tom Morgenfeld on the 30th of October. Early tests with the first aircraft were marred by undercarriage retraction problems, but once these had been rectified, the program accelerated. Lockheed's flight test team demonstrated supersonic flight on the 25th of October and qualified the YF-22 for in-flight refueling soon after. Unlike Northrop, Lockheed elected to demonstrate missile firing, launching an AIM-9 Sidewinder on the 28th of November and an AIM-120 AMRAAM on the 20th of December. The envelope was rapidly expanded through a series of flights to demonstrate supermaneuverability, thrust vectoring being employed for the first time on the 15th of November. The first aircraft was fitted with a spin recovery parachute for these tests. Supercruise, the ability to fly supersonically without afterburner, was a key requirement for ATF and was first achieved on the 3rd of November. During DEM-VAL, the two YF-22s flew 74 times between them and demonstrated all key parameters. They also demonstrated several achievements that were not required by the contract. On the 31st of December 1990, Lockheed submitted its proposals for the Engineering, Manufacturing and Development, or EMD phase. Results from the flight tests, backed up by thousands of hours of wind tunnel data, computer predictions, manufacturing proposals, and other supporting information. The proposal was 20,000 pages long. After long deliberation of the two proposals, Secretary of the Air Force Donald Rice announced that the Lockheed team was the winner on the 23rd of April 1991 and that Pratt & Whitney had been chosen to develop the engine for the F-22. The choices were made on the grounds of cost for capability, lower technological risk, and program management issues. Northrop's YF-23 apparently outscored the YF-22 in some key areas, one exception being maneuverability, but was generally felt to be too risky a prospect. The EMD contract called for 11 prototypes, of which 2 were to be F-22B two-seaters. When it became apparent that conversion to the F-22 could be adequately achieved by the use of simulators, the trainer version was dropped to save money. Lockheed's first EMD aircraft, Raptor 01, was rolled out at the production plant at Marietta, Georgia, on the 9th of April, 1997. It first flew on September the 7th. While obviously based on the YF-22, there were notable differences, such as new planform for the wings and tailplanes with reduced leading-edge sweep and smaller fins. The engine intakes were also cut back to improve visibility from the cockpit. Lockheed Martin built 9 EMD aircraft in total, the first 3 lacking avionics. The second aircraft, seen here, flew on the 29th of June, 1998. It was used for much of the out-of-envelope flight testing, for which it was fitted with a spin recovery chute on a gantry between the tails. Raptor 04 was the first with radar, flying in November 2000. But it was Raptor 06 that became the main avionics testbed. Production of F-22 sub-assemblies takes place at various sites. Lockheed Martin's Fort Worth site builds the core central fuselage. While the plant at Marietta builds the forward fuselage, complete with cockpit. Boeing in Seattle builds the aft fuselage and the wings. While Lockheed Martin builds the radome and other sub-assemblies at Palmdale. Components are brought together for final assembly at Marietta. Lockheed Martin pilots fly a number of early production test flights, with the aircraft often still in primer. Marietta also has a special bay for applying radar-absorbent material and another for verifying radar cross-section. When these checks are complete, the aircraft is formally handed over to the US Air Force.
次号は FA18 ホーネット。アメリカ海軍の多用途艦載戦闘機として就役したホーネットは、一度の出撃で空対空戦闘と空対地攻撃をこなせる多用途戦闘機です。次号ではそのホーネットを徹底的に分析します。ぜひお買い求めください。